Black holes are formed when a massive star runs out of fuel and collapses under its own gravity. The collapse creates a singularity, a point of infinite density, and zero volume. The singularity is surrounded by an event horizon, the point of no return. Anything that crosses the event horizon will be pulled into the singularity and destroyed. Black holes are fascinating objects that have captured the imagination of scientists and the public alike. They are still not fully understood, but they are thought to play an important role in the evolution of the universe. Black holes can be classified into three types: stellar mass black holes, intermediate mass black holes, and supermassive black holes. Stellar mass black holes are formed when a star with a mass of more than 20 times that of the Sun collapses. These black holes are thought to be common in the universe. Intermediate mass black holes are thought to be formed when two stellar mass black holes merge. These black holes are much rarer than stellar mass black holes. Supermassive black holes are thought to be found at the centers of most galaxies, including our own Milky Way galaxy. These black holes are millions or even billions of times more massive than the Sun. Black holes are still a mystery to scientists, but they are an important part of the universe. They are thought to play a role in the formation of galaxies and the evolution of stars. Black holes are incredibly massive objects that warp the fabric of space-time around them. This warping is so extreme that not even light can escape, which is why they are called black holes. Imagine a bowling ball on a trampoline. The bowling ball creates a dent in the trampoline, and a marble rolling nearby will be pulled towards the bowling ball. This is similar to how a black hole bends space-time, causing objects to be attracted to it. The warping of space-time around a black hole is so strong that it can cause light to bend as it passes by. This is called gravitational lensing. Gravitational lensing can be used to study black holes and other objects in space. Here's an image of how a black hole bends space-time. As you can see, the space-time around a black hole is curved. This curvature is what causes objects to be attracted to the black hole. Time and black holes are a fascinating topic. Einstein's theory of relativity says that time can be affected by gravity. Near a black hole, where gravity is incredibly strong, time would slow down compared to how we experience it on Earth. Imagine a clock falling towards a black hole. As it gets closer, the clock would appear to tick slower and slower to someone watching from a safe distance. Eventually, the clock would seem to freeze completely at the event horizon, the point of no return around the black hole. However, for someone on the clock, time would continue to pass normally. They would experience crossing the event horizon and falling into the black hole in a finite amount of time. This difference in how time is experienced is a mind-bending concept, but it's a prediction of Einstein's theory of relativity that has been supported by observations. Here's a breakdown of what might happen if you were to enter a black hole, keeping in mind that we don't have direct observational data. 1. Tidal forces. Spaghettification. As you approach a black hole, the gravitational pull on your feet would be significantly stronger than on your head. This extreme difference in gravity would stretch you out like spaghetti, a process called spaghettification. 2. Event horizon. Point of no return. The event horizon is the boundary around a black hole. Once you cross this point, there's no turning back. The escape velocity, the speed needed to escape the black hole's gravity, exceeds the speed of light, making it impossible to escape. 3. Singularity, the heart of darkness. At the very center of a black hole lies the singularity, a point of infinite density and gravitational pull. Our current understanding of physics breaks down at this point. We don't know exactly what happens to matter that reaches the singularity. Hypothetical scenarios, beyond current understanding. Passage to another universe. Some theoretical models suggest that black holes could act as portals to other universes or dimensions. This is purely speculative and has no observational evidence. Information paradox. One of the biggest mysteries surrounding black holes is what happens to information that falls into them. Does it disappear forever, violating the laws of physics? Or is it somehow preserved in a way we don't yet understand? Important notes. This is a highly simplified explanation. Black hole physics is incredibly complex, and our current understanding is limited. These scenarios are theoretical. We have no direct observations of what happens inside a black hole due to the nature of the event horizon. In summary, entering a black hole would be an incredibly dangerous and likely fatal experience. The extreme gravitational forces would tear you apart, and you would ultimately be drawn into the singularity, where our current understanding of physics ceases to apply. Let me know if you'd like a more detailed explanation of any of these concepts. Comment below.